Have you ever looked up at the night sky and felt a chill kick in, as though some ancient secret was staring back at you? Because tonight we're going into one of the most frightening and awe-inspiring corners of the universe, the howling darkness of a black hole. Not just the idea of one, but the brutal reality, the strange consequences, and what it might mean for us. Picture this. A region of space where gravity doesn't just pull, it devours. Where up is down, time slows, and you vanish without a trace. If that doesn't send a shiver down your spine, stick with me, because by the end, you'll understand not only how black holes work, but why they might change how we see ourselves in the cosmos. Let's start simple. A black hole is a place where gravity runs wild. According to Einstein's theory of general relativity, mass and energy warp space-time itself. But if you compress enough mass into a small enough region, the warping becomes extreme. Nothing inside a critical boundary, the event horizon, can escape, not even light. Now that's the textbook explanation. But here's the twist. A black hole isn't some dense sphere of matter like a planet. After the collapse of a star, in the stellar mass case, or the gradual growth of a supermassive monster, what remains is space-time itself, bent into a point of no return. The object is essentially invisible. We detect its footprint. Astronomers often talk about the types of black holes: stellar mass, around tens of times the sun's mass; intermediate, hundreds to thousands; and the truly gigantic supermassive ones lurking in galactic centers, millions to billions of times the sun. Understanding these types matters, because each reacts differently with their environment, and the stories they tell are very different. More than just curiosities, they're clues to how the universe evolves. You might think, how can we see something that swallows light? It's a valid question. But we don't detect the black hole itself. We detect the havoc it wreaks around it. Imagine a star orbiting something invisible yet massive. The orbit bends, speeds up. We infer something massive is there. Or picture a swirl of hot gas, spiraling at near light speed, heating up, glowing, until at the edge it disappears into nothing. That glowing ring around darkness is the shadow of a black hole. In April 2019, the Global Telescope Network Event Horizon Telescope, EHT, captured the first direct image of a black hole's shadow in the galaxy Messier 87, M87. Here's an important insight. Even though the black hole itself emits no light, the extreme gravity bends light around it, and the hot material around it glows. So we see a ring of light and a dark center. That is our visual of the impenetrable. What's more, the image validated Einstein's predictions and opened a new era of seeing gravity at its fiercest. It's the cosmic equivalent of looking death in the eye, literally a shadow of nothingness surrounded by blazing matter. Now let's imagine you are the Voyager. Forget sci-fi shields. Assume you have some indestructible suit and spacecraft. You set course for a black hole, and you cross the threshold, the event horizon. Right after crossing, your journey changes entirely. First, space becomes stretched, time becomes twisted. If you look outside your cockpit, you might see someone far away age rapidly while you crawl along. In your reference frame, you're fine, but time for you slows relative to outside. Then there's the infamous spaghettification. Because of the extreme gravitational gradient, your feet are felt more strongly than your head. Your body begins stretching into a long, thin strand, like spaghetti being pulled through a pasta maker. Your spacecraft disintegrates. Molecules unravel. You reach essentially a point with no physical form as we know it. And then the singularity, the ultimate endpoint. A point of infinite density, infinite curvature of space-time. Our physics fails there. We simply don't know what happens. Some theories say you are crushed to nothing. Others speculate new physics emerges, but one thing is certain. For you, the journey ends. No return ticket. To make this vivid, consider the story of scientists trying to capture the black hole image. The EHT team, spanning dozens of observatories around the world, had to synchronize radio telescopes across continents, build an Earth-sized virtual telescope, and process petabytes of data. Imagine standing on a frozen plateau at the South Pole, part of the network, waiting for the radio bursts, battling extreme cold, logistical nightmares, data storage issues. The goal? To photograph the unphotographable. That's how serious this quest is. Another example. Consider how scientists detect black holes by watching stars orbit near the Milky Way's center. One star, known as S2, orbits the object we call Sagittarius A star roughly every 16 years, reaching extreme speeds. The only explanation, a supermassive compact mass at the center. That's not fiction, that's observation. These stories show the human side of it. Thousands of nights, blinking telescopes, mountain observatories, code that crashes, data that needs fusion, and all of it to see a shadow. In doing so, we push our technology, our understanding of physics, and ultimately our idea of what reality means. Here's where things get wild. If you accept that black holes exist, we do, then what about what they mean? Some physicists speculate that black holes might connect to new universes, or that the universe we inhabit might itself be inside a black hole of some larger cosmos. Think of it this way. Black holes collapse into singularities. Maybe at that singularity, a new Big Bang occurs, spawning a new universe. It's pure speculation, but it's grounded in the idea of space-time geometry and extreme gravity. Another intriguing possibility, the phenomenon we call dark energy, the force accelerating the universe's expansion, might be connected to matter falling into black holes in some higher dimensional framework. Could the missing energy come from beyond our universe's event horizon? These aren't idle fantasies. They're serious topics at the frontier of theoretical astrophysics. Sure, we don't have proof, but the fact that we can ask these questions means we're pushing the boundaries of knowledge. So you might ask, okay, cool, but what does this black hole stuff have to do with me? A lot, more than you might think. First, it expands our understanding of physics. The extreme conditions inside a black hole push gravity into regimes we cannot recreate on Earth. By studying them, we test Einstein's theory, probe quantum gravity, and deepen our grasp of reality. Second, it humbles us. A black hole reminds us how small and fragile our existence is. It also shows how much we don't know. That's a powerful motivator for human curiosity. Third, in a figurative sense, black holes are metaphors. They teach us about limits, of knowledge, of escape, of fate. When we study them, we're studying the boundaries of science and of ourselves. Finally, the technologies developed to observe black holes, global synchronized telescopes, data algorithms, imaging techniques, often spin off into everyday tech, so the ripple effects matter. Here's where I want to add my own thoughts. We often think of black holes as monsters, sucking everything in, merciless, final. But think of them differently, as gateways to understanding. Yes, the monster imagery is powerful and helpful, but it can also mislead, because it tends to keep people at a remove. That's out there, scary, unrelated to me. Instead, what if we treat black holes as laboratories? Because that's what they are, laboratories of extreme physics. They test the limits of time, space, mass, even information. Another assumption, that black holes are beyond hope or escape. And yes, crossing the event horizon means no return. But the processes around a black hole, accretion disks, jets, radiation, are dynamic, violent, creative. Matter falling in can light up galaxies, launch jets that stretch across thousands of light years. Black holes are destructive, yes, but they're also engines of change. Finally, let's challenge the idea that the universe is static or safe. If we accept that black holes are common, every galaxy likely has a supermassive one, then we accept that the cosmos is not gentle. It is dynamic, dangerous, mysterious, and that's a good thing. It means we have real frontiers left to explore. So here's what I hope you take away. Black holes are more than science fiction monsters. They are real, extreme, and central to our understanding of the universe. Approaching a black hole means confronting limits of escape, of time, of the physics we know. But it also means opening doors to new ideas. Our ability to see black holes now, through networks like EHT, is a tribute to human curiosity and collaboration. And finally, the study of black holes reminds us that knowledge has boundaries, yes, but it also invites us to push past them. We may never cross a black hole event horizon ourselves, and that's fine. What matters is that we continue the journey of discovery, that we keep looking into the darkness and asking what's next. If you leave this video thinking, the universe is larger, stranger, and I live in it, then we've done our job. Because that sense of wonder, of humility, of curiosity, is what moves science forward. Thanks for watching. Don't forget to like and subscribe if you want more deep dives into the universe's weirdest corners. Until next time, keep looking up.